Okay, so trapezoid. A trapezoid is a quadrilateral, I'm just going to abbreviate as quad. It's a quadrilateral with only one pair of parallel sides. It's a quadrilateral with only one pair of parallel sides. Quadrilateral with only one pair of parallel sides. Okay, so let's just think about these little pictures here real quick. Decide which one of these are trapezoids. Is this a trapezoid?
No.
Okay, no, it's not. Why not? Good, it has two pair of parallel sides. These two sides, I mean, just by what it looks like, those two look like they're parallel, and these two look like they're parallel. And for it to be a trapezoid, it can only have one pair of parallel sides. So that's a no on that one. What about the second one? Yes, because this side's parallel to this one. The other two sides are not parallel. What about that next one?
No.
It's no. Because this side's not parallel to this one, and this one's not parallel to this one. Okay, what about the next one?
No.
No. Because this is parallel to this, and this is parallel to this. What about this one?
No.
It says no also. It has two pair of parallel sides. What about this one?
Yes.
Yes, because this is parallel to this. The other two are definitely not parallel. What about the next one?
Yes.
Yes, because this side is parallel to this side. What about the next one? No, because this side's parallel to this one, and this side is parallel to this one. What about the next one?
No.
Nope, same reason. What about this one? Yes, this side's parallel to this one, and then the last one?
Yes.
Yes, this side is parallel to this. So in general, that's what a trapezoid is. It's a four-sided shape where only one pair of sides are parallel. The other two sides are not going to be parallel. Now we can be more specific and talk about an isosceles trapezoid, and that's what we're going to talk about for a little bit. So a trapezoid in general is what we just talked about, but isosceles is an even more specific type of trapezoid. So this is just like an isosceles triangle. What does it mean to be an isosceles triangle?
Two sides of the same.
Okay, good. Two sides are the same or congruent. I was going to put this symbol. Isosceles triangle means two sides are the same. Isosceles trapezoid means two sides are the same. Okay, so in an isosceles trapezoid, each pair of base angles is congruent. Okay, in an isosceles trapezoid, each pair of base angles is congruent. Okay, if a trapezoid has one pair of congruent base angles, then it is isosceles. So basically, this and this are just the converse, pretty much. Like this are just in reverse. And the last one here is a trapezoid is isosceles if and only if its diagonals are congruent. So in an isosceles triangle or trapezoid, the diagonals are congruent. All right, so on this first one right here, this angle is 55, and this is an isosceles trapezoid. We could tell because it says that this side is the same length as that side. So it's a specific type of trapezoid where this side and this side are equal. So whenever you have an isosceles trapezoid, the base angles are congruent. So angle 3 is congruent to this angle, which is angle C. So that's 55 degrees for that one. Now, what do you think would be true of angle 2 and angle 3 since these two sides are parallel?
You will make it 90.
Okay, close, but not exactly. Well, not close, but you got kind of the right idea. What do you think is going to be true of these two angles? They add up to 180, yes. Okay, remember these are like what we talked about a long time ago, same side interior angles. Well, it's not like they are. These are same side interior, they're supplementary, they add up to 180. So if this one's 55, and these add up to 180, how am I going to find this one? Good, I'm going to do 180 minus 55, and what does that give us? What does it give you? 125, which means angle A is 125 degrees. Okay, next one, if angle L is 145. Angle K is 145. How big is angle J?
35.
Is 35, which means angle M is 35.
Wow.
Wow is right. Okay, on the next one, if angle C is 127, angle B is 127, how big is angle A?
143.
Is what? Is it 53? Bless you.
Thank you.
It's 53. Remember that up to 180. Okay? So basic stuff there. Now this next one is not necessarily an isosceles trapezoid. In fact, it's not. But what's true here is still the same. Is what do I know about these two angles right here? They're same side interior, so what do I know about them? They add up to 180. Whoops, sorry. So it's going to be 61 plus 3x plus 65 equals 180. Right, all I'm doing is doing this one, the 61 plus 3x, plus this one to equal 180. Okay, so we're going to combine like terms here, which the 3x is by itself, so that just stays as 3x. What's 61 and 65 make? 126 equals 180. We're going to subtract 126 on both sides. So 3x equals 80, 60, 54. Divide both sides by 3. And so x equals 18. Yep. Okay, number 7 is the same thing. I'm going to go ahead and skip that one for now. The same idea. Those two would add up to equal 180. Okay, on these last three is going to go up to the last thing that we talked about up here. In an isosceles trapezoid, the diagonals are congruent. All right, well, that says it the other way around, but same idea. Okay, so this is an isosceles trapezoid. I know that because of those marks. It says that Km from here to here is 22. And the question is how long is JL? It's going to be 22.
Wow.
Yes, exactly.
That's impressive.
Okay, next one it says EC is 20. Okay, and FD is 5x minus 10. Okay, good. That's right. So we're just going to set those equal. 5x minus 10 equals 20. Since this is an isosceles trapezoid, the diagonals are congruent. Add 10 to both sides. 5x equals 30 divided by 5. X equals 6.
Wait, you did that too fast.
On the back. So another thing about trapezoids is what we call the mid-segment. All right, the mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the leg. The length of the mid-segment is 1/2 the sum of the length of the bases.
It's so new.
Yes.
Like the Midwest.
Okay, so on this one right here, this line right here is what we call the mid-segment. Okay, that's called the mid-segment. And you can see why it's called that. This end of the mid-segment is halfway between E and D, and this end of the mid-segment is halfway between C and B. So what ends up happening with this mid-segment is that, well, in a trapezoid, this side is parallel to this side, but the mid-segment is parallel to those sides. So all three of those are parallel. And the most important thing is that the mid-segment is the length that is exactly halfway between the two sides it's parallel to. So, for instance, on this one, as I look for this mid-segment QP, the length of QP is going to be the number that's exactly halfway between 34 and 22. What's halfway between 34 and 22? It's halfway between 34 and 22.
Wait. 27. It is 17. Well, what was I thinking?
It's got to be halfway between 22 and 34.
17.
It's got to be halfway between 20.
Shut up, Andrew. No one asked you.
Okay? So somebody said it right off the bat. It's 28. Let me show you the easy way to do that. I mean, there's more than one way, but this is the way we're going to do it. We're just going to average it. So we're going to go 34 plus 22 divided by 2. So I just do this plus this divided by 2. And what does that give you? It gives you 28. Think about it like this. How far is it from 22 to 34? It's 12. From 22 to 34 is 12. What's half of 12? 6. If you do 22 plus 6, that gets you to 28. And if you do 34 minus 6, that gets you to 28. So 28 is 6 units away from there. It's 6 units away from there. All right. So on this one, what's halfway between 8 and 30? This side is 8. This side is 30.
38.
It's halfway between 8 and 30. Okay, so we're going to go 8 plus 30 divided by 2. And yes, it is 19. Okay, on this one, what's halfway between 47 and 83? $65. Okay, what's halfway between 20 and 38? It's 29. Okay, now this last one, we know the mid-segment. Okay, this time we know the mid-segment's 90, and I'm looking for this shorter side up here. So there's a lot of ways to do it. To me, the easiest way is to think about it like this. How far is it from 99 to 90? 9 units. So it's got to be the same distance from here down to the shorter side. So if it's 9 units down to the shorter side, what's it going to be? It's going to be 81, just 90 minus 9, so it's going to give us 81 feet for that one. Okay, then the last thing is a kite. Okay, a kite is a quadrilateral with 2 pair of congruent consecutive sides. Okay, a kite is a quadrilateral with 2 pair of congruent consecutive sides. Quadrilateral. I'm just going to abbreviate it as a quad. It's a quadrilateral with 2 pair of congruent consecutive sides. So a kite is actually a geometric shape, okay? And this is basically what it looks like. And what that definition of it means is this, is that this side and the consecutive side are congruent, like that side. And then this side and this side are the same length. Okay, so these 2 sides are the same, these 2 sides are the same, but this set of sides is not going to be the same length as these 2 sides. So it's just like if somebody asks you to draw a kite, this is basically probably exactly what you would draw like, where you make these 2 the same, and then you make these 2 the same. Now, in a kite, there's 2 main properties. The first one is that the diagonals are, and with that little thing right there, John, what do you think we're going to put here? Okay, 90 degrees, what's the fancy math word for that? If 2 lines are 90 degrees to each other, what do we say about them? Okay, complementary means they add up to 90, so that's good, but that's not what I'm looking for. They're what? When they make 90 degrees with each other. It's a word we've talked about very recently.
Congruent?
Not congruent.
What does it start with?
Starts with a P.
Parallel.
Not parallel. Do these 2 look like they're parallel?
Perpendicular.
There you go. Perpendicular.
Where did you even come up with these words?
I didn't come up with these words, I promise. The diagonals are perpendicular. And again, perpendicular is just a fancy math word for being 90 degrees to each other. Okay, so that's one property of a kite, which is the same truth of a rhombus that we talked about that we just used on a quiz a little bit ago. Okay, and then the other thing is in a kite, there's exactly one pair of opposite angles that are congruent. Okay, exactly one pair of opposite angles that are congruent. And if you just think about a kite, I mean, it's very symmetric, like going along this way. And you can tell how these two angles are going to be the same. So in this case, G and J will always be the same. F and H will not be the same in a kite. These two will always be different. These two will always be the same. So down here on number 1, as I look for angle A, you think angle A is going to equal? It's 120, yes. Because, I mean, it's just easy to see. It's easy to see in a kite how these two angles would be the same. Angle B and angle D would not be the same. All right, on number 2, it's asking for angle R. But first, how big is angle S?
122.
Is 122. Now to find angle R, since we're dealing with the quadrilateral, 4 sides, what do you think the 4 angles add up to? 360, exactly. So I would go 360 minus 122 minus 122 minus 50. What does that give you? Yep, 66. All right, number 3. We're looking for angle Z. Well, I know angle Z and angle X are the same. So here's what I'm going to start off with doing. I'm going to take 360, subtract off the 81, subtract off the 41. So if you do 360 minus 81 minus 41, what does that give you? Okay, 238. So there's 238 degrees left to split evenly between these two since they're the same. So we have 238 degrees to split evenly between these two. So what am I going to do? Divided by 2, yes. So it's just going to be 238 divided by 2, which is 119 degrees. Okay, on this next one, so since this is a kite, these two sides are congruent, these two sides are congruent. So to find the value of x, we're going to set those equal and solve for x. So I'm going to go 6x minus 37 equals 3 plus 2x. All right, and just solve for x. So subtract 2x on both sides. That's 4x minus 37 equals 3. Add 37. 4x equals 40. Divide by 4. X equals... yes, equals 10. Now to find KL, okay, that's for KL. I'm going to take this 10 and plug it in right here. What's 6 times 10?
60.
And 60 minus 37? It's going to be 23. Okay, on this last one. So on this one, again, well, if this angle is 114, this is the symmetric part of it. So this is going to be 114. And then what do I know about all 4 of these angles? They add up to 360, yes. So it's going to look like this. I'm going to take the 8x minus 7. Okay, that's this angle. Plus the 114. That's the angle next to it. Plus the 51. Plus the 114. And together, those all add up to equal 360. All right, so I'm going to combine like terms. Negative 7, 114, 51, and 114. 8x is just going to stay by itself right now. So it's negative 7 plus 114 plus 51 plus 114. Is what? Is 2 what? 272. Okay, subtract 272 on both sides. 8x equals... Well, it equals 88, right? Divide both sides by 8. And so x equals 11.